being a product specialist is a pretty cool thing. I get a chance to see so many unique applications and meet so many different people across the country. My travels go right across Canada, parts of the United States, Alaska, and some of the really interesting applications that I get involved with are very rewarding. I find them very rewarding to help solve a problem like you're going to see today on this video. Usually, as a product specialist, our leads are generated internally by our salespeople or our managers or whatever, because they're calling on the customer and they're interacting, listening to their problems. This particular account, it's a big pulp and paper mill just northwest of Edmonton, a couple hours. This one was generated by themselves, and somebody had been at an association where I was doing a talk on seals or rotating equipment or whatever, and I happened to talk about seals enough that piqued their interest, and this particular engineer then tossed me the baton when they were having some sealing problems, what they call the Toonie press. So it's kind of like a screw conveyor. You're going to see it here in a minute. With it takes pulp and paper, which is just terrible stuff on bearings. And when the pulp gets into the big bearings and the bearing housing that we're gonna spend a lot of time looking at today, and it affects the bearings fail. And it's kind of interesting. The mean time between failures. I'm always trying to generate cost savings. I think cost savings, documented cost savings, are very, very important, especially with large corporate contracts like what we're dealing with here. When I talked to Elliot, I interviewed him, and we asked about the cost savings on the very first visit, and they're getting about 3 months mean time between failures before the bearings fail, before all the crud gets past the typical lip seals that the OEM has on there now. And so those failures cost about $20,000 each, and our goal is to get a 3-year runtime with these new Meco seals, and that's what we'll be looking at today, is putting on the new mechanical Meco seal. It's a product seal, and so if we achieve our goal of 3 years, and the reason why it was 3 years is the screw conveyor itself lasts about 3 years, the flighting lasts. So 3 months is not acceptable, 3 years would be acceptable. If we achieve that goal in these 3 machines, that's a year period, it'd be $750,000 saved for this particular account. So that's actually substantial. So that's why we spend so much time and energy and capital in putting the effort into to try and find these solutions. We paid to fly in Paul Worley, who's the chief engineer with Meco Seals out of Maine, USA, to help us on this very first and critical application. We wanted him to be there to help with the installation and make sure everything's going exactly the way it should, because it is critical, but also at the same time to train the staff at this particular mill on how to put everything together. So the purpose of this video is twofold. Number one is for our own people internally, so that they can actually learn from this experience and find out there's lots of other applications at pulp mills and all kinds of different plants all across Canada, where our people could actually take a look at this video and see that there is a real opportunity, one, to profit for the company, but also to profit for the end user, which I think is a real win-win for everybody. The second purpose of this video is to document the whole thing for the end user, for Elliot, so that he, has a good video documentation, not only for the Meco seal, but you'll see probably 3/4 of this video is the struggles that these guys go through with these big, huge, massive bearing housings. And so we documented everything, and I think it's going to be good for the customer to have this for when new millwrights come on board. They can actually view the video, and it saves them a lot of mistakes down the road. So anyways, there is going to be some background noise with what's going on here in a shop. We at least are in a shop, not way up on a machine where we can't get good video footage. So we got some real quality video footage. I edited it the best I could and dubbed in words so that you can see what we're doing along the way. So I hope you really enjoy and you can learn something from this video, the capabilities of what product specialists bring to the table.
Here's a good look at the Toonie press when it's in service with the cover and casing on. Here's a little bit of a shot of what the input seal looks like, all messed up. And here's a kind of a little look-see in the shop, what everything looks like outside of that case. Here's a look at the bearing end, where the bearing's going to be, where most of our work is going to be done today, is right here in this section.
I'd ask you a question. When you have the seal,
it's not critical.
here we have it. This is the top. It's on the thrust. It looks like stationary. So it's a thrust bearing. Since it's soft face sealing technology, you don't run a rock
There's no set torque on those then, Paul? Just
torque number I like to use is, I don't have it measured, 15 to 20. You'll feel it kind of go snug on you. We actually got a new design coming out in about 6 months.
so you're actually tightening it, Paul?
Yeah.
Yeah, because there's just a tiny bit of gap there.
Well, we leave them loose when you ship them.
Oh. Yeah.
Otherwise, it's under load. It's PTFE.
Yeah.
It's cold flow on you.
Okay. And so you have a new design coming out?
Yeah. Uses a new screw and with a shiplap register. But I think you might want
perfect.
Assemble it together.
I think you might want to just glue this on the shaft. Use the shaft as a fixture.
Oh,
Put
okay.
a little, love juice on there. Just put a thin coat on one end.
Then use the shaft to guide it.
Use the shaft to guide it. Don't worry about gluing it to the shaft. Line it up. Apply pressure. Count to about 15 slowly.
Okay.
And then it's done. Then break it free from the shaft. And then pull it off. And then we'll put these rotors on. That way we don't put any glue. We don't have the rotors in the way. Don't have the rotors in the way.
Yeah, we're just using this to guide
You're saying that next time what we should do for the next one of these is consider not having split?
It's not having a split drive and elastomer. Or you cut it here, or you include it with a split driver and an unsplit driver.
Okay.
So that way you've got the flexibility.
depending on if you have to do an application
we are here,
versus
where this is the least expensive part.
Yeah.
And it's also the weakest link and the most critical.
yeah, and if you split it, then you're not faced with trying to split it here. So
Yeah.
Exactly. It's a Loctite product, and then you just rubbed it over top of the
joint.
Where
the
glue
joint
joint is.
afterwards, and it waterproofs that joint.
Yeah.
Where the next time what we're going to do is go with no cut, so we won't have a joint. Really.
Yeah.
Yeah. That's pretty cool. I honestly don't think I've seen this. So, and that is a Loctite product. It doesn't
Comes
look.
in the O-ring kit.
You got to be kidding me. That's in an O-ring kit.
Yeah.
So,
Slicing kit.
okay, perfect. So you're hoping that will just get far enough out of the way to allow the housing, eh, Paul?
Yeah, what's our distance here?
In our procedure, let's note that we got to put the screws in first.
Yeah, so put the screws in first. And we're trying to create enough radial room here so that we can assemble that bearing housing and then if we have enough room, this stays in, then we push it over, and then we make the others, we put our other split part. We might end up having to take this apart as well. We're not sure. So we're just hoping we've gained enough real estate. Okay, perfect. And so far, Paul, we've just basically, you know, we built our elastomer, we tightened up our little peak. Those are peak?
No, those are PTFE.
PTFE. Okay, perfect. Okay.
The only function of the O-ring on the assembly, it's an assembly bolt, is to hold the bolt in place. That's its function. It's not to seal, it's to keep it held in place.
That's just for shipping?
No, for shipping, for tight linear spaces. You're having to install a seal in a tight space.
Oh, okay.
And you don't want to have the bolt.
Oh, so they'll be used afterwards. Oh.
Yeah.
Oh. Well, that's kind of cool.
Yeah.
So it's actually a little trick to hold the bolt in place so it doesn't
fall out in tight axial spaces like we have.
I like it. So we're setting up the sleeve 54 millimeters from here. We're going to Loctite it right on here with some primer. That's really the first step.
Do the inside of the sleeve too with the primer? No.
Shaking like I drank it.
It'll run around the wall.
Yeah. We can just turn the sleeve.
Yeah, you just push it on and then turn it as you pull it underneath. And turn it as it's on. And pull everything.
Setting up quick. That's good, I think. The oxygen's going.
Is it on already, eh? Good primer. That really held quick, didn't it?
That was fast.
Yeah, that was very.
This next step is probably the most critical step of the whole procedure, and you can see how Scott is trying to get that big thrust bearing all the way past a bunch of steps that are fairly tight, and once he gets it past this next little step, he knows exactly where the thrust bearing is supposed to go, and he's testing right now just to see whether that thrust bearing is going to be able to be put on there, because you'll see in the next segment all this is done blind. The housing is over top of that thrust bearing, and you have to be sure that this thrust bearing is being it's going to go all the way to the home position. So you'll see right away he gets it past the last step, and this is the critical part that took us quite a few hours to get right, because we put this bearing on. It's not going to work, and you'll see right away we have to emery it and take it down. Okay, and you can see here, second attempt, and so we finally now know, or Scott and the guys feel comfortable with the bearing going in that position. So the final preparation here now for the bearing housing, put a little grease there, Scott's sliding the bearing housing carefully, and there's no bearings inside this at this point. This is just the empty housing. We've done all our preparation, make sure everything's ready to go. The Meco seal is in the back position, waiting for the bearing housing, and then we'll deal with that later on. And so there's the housing, and everything starts from here. Scott is going to be putting on the thrust bearing inner race. This is the easiest step of the whole procedure. This is about the only thing that's simple here, as you'll see. There's a set of springs that Scott had to make sure was in there before he put that race in, Now we're just lubing up the thrust bearing, pre-lubing it. And then this is the all the preparation before makes this job easier. At this point, the guys now are able to know that the thrust bearing is all the way home.
So you're now putting the other sleeve in position, eh?
Yeah.
Here, I'll hang on to that for you.
Make sure
That primer we just learned sticks like quickly. I will hold on to it. There looks like there's a right and a wrong way. I think it goes on that way, right? I'll make sure I don't hand it to you wrong. You might get angry very fast.
I'm not the one you gotta worry about getting angry. Dave's the one you gotta worry about.
Uh-oh. No, that one's a little easier because no messing around, eh? Is it already on there? Solid?
I guess this is the next easiest step. The split collar goes in pretty easy as well. Very simple part of the procedure. The next bearing is a little bit more difficult again. The very last step is the double row spherical roller bearing, the radial side of the housing, and the guys are just tapping it into position, and it's got a tapered adapter, and so you'll see them take the clearance out of the bearing. They measured the bench clearance. They'll do a final check, as you can see right now. On the clearance, we're almost done. We'll be putting the cap on right away, and then we're going to start to work on the seal. This almost took all day. And then we're back to the seal, which takes about 20 minutes, it seemed, in comparison.
This is city work.
And it's like federal government job, not a provincial government job.
I've seen this in union jobs.
Well, I've worked for the federal government now. You get to become a professional looking like you're doing something, but really doing absolutely nothing. That's the difference.
How much? Elliot went in there and measured, man. So now we're done everything and we're actually back to the seal.
Yeah.
Okay.
Yeah. Finally. Well, long story short, yeah, we're back at the seal.
Now we're actually 8 o'clock this morning where we started.
Yeah, that's where we are. So we're here about to see.
Adapt to you and adapt to me. Yes. And it fits.
Old circle, that's one wall. They all
That's
it would be so hard to turn the wall.
Yeah.
It's gravity working. Because I hold
The same thing the bearings are. That's right.
That's like sticking a piece of.
Oh, so you're just holding it up, Paul?
I'm just holding up so it's easier to turn the capsule. Short one down, that'd be smart. Worthwhile.
Use this to zero.
Stuffing the seal in.
Spend a lot of time and money making that happen. Now the next cover plate will pull that together on knot.
Makes sense.
What's the favorite? Let's go. You look for
Those screwdriver, like the two that are right here.
Like those two, those are mine.
The current one.
There's two on the floor.
Taller, it's a specialty.
That's for picking your nose around corners.
Non-interference fit taking place. So if you're having trouble, if it's really easy to put on, that's a bad sign. And on the second one now, when you get to the second one, and it's going to be, I think you're in. valve. That appears to be where its home is. That's its home position. And now on the second rotor, start fitting it where it's the most difficult to put your hand, which I would think would be 6 o'clock. And then you hold it and you just apply pressure, and it'll pop over. You got to continually apply force on it.
On the second
On the second rotor. And that's where I go back, start over. Is it in? Nope, there's about a 3 millimeter gap.
Yeah, that's pretty good.
I'm seeing shadows. Now, it's interesting. We have split rotors, split yellow components, split drive elastomer, split inboard stationary seal head. If we were to do it again, do any of those, do we want to keep them split? It's going to be something to...
Yeah, I think so, because then we can pre-assemble all this stuff and then come in later and put that in. Right? Okay, I think that's probably the best way.
Yeah. Well, you know, when you go try to glue that drive elastomer in there, just in that space.
So we're putting on the last piece, eh?
Yeah.
And then some RTV on the cut lines.
Yeah.
Is it this one what we were using before? I think that was what we were using this.
Yeah.
Oh, he already put it on? Fuck, he's fast.
Just sits on 2x6 or 2x8 stage trade one.
I got it right now. Yeah, it's on. There's one tire. One of the 4 is on drive. The other 3 are on garage. It's off the end of the driveway. Like I said,
So we're almost done, eh?
yeah.
Oh, it looks pretty good. After the whole day, it was kind of anticlimactic. Just the seal part didn't take any length of time.
No, if we'd have known, we should have just got the bearing in it.
More or less, yeah.
Yeah. We want you back next week, Paul.
Oh, good. The gauges are high. It's open down below. You got the plug in it.
Yeah, got the plug in there.
Thank God that gauge.
I see what you're trying to do. Just a fine touch, eh? So you're not going to open it up. And...
Oh no, no. It's going to hold pressure.
So we're up to 50 already?
No, that's
70.
Oh, good.
Yeah. Look at the
I was going to say.
It's KPA, yeah. That's good there. Right there.
So we're holding
You
8.
hold it there, right?
Yeah, we can take the air off.
No, it's going to bleed out.
It will.
Bleed.
Oh.
Oh, yeah. Absolutely. Yeah, it's not a hermetically tight balloon.
Yeah, that's right too. I guess.
Think about
it's
all
just-
this.
Right. Okay.
So like, go back to that. If you can just hold it at that 7 and just back away from it, or and then we'll just feel around and see if we feel. Because ideally, we have a regulator here with a gauge on it, and so then we're reading the 2 gauge pressures. One's reading the line pressure, and this one's reading the cavity pressure.
Right.
And if you see a large differential, something's up. You know. So now we don't feel anything, we don't hear anything.
Don't make an air sound.
Now open the bottom valve. Put your flashlight.
Yeah, I got it. Okay.
Away she goes.
Barely anything though. Is it fully open?
Yeah.
It's like
But it's still flowing because that's on.
It dropped.
It dropped.
It's a dying breath, but it's barely open, right? That's where I talk about, maybe I haven't spoken about it enough. Maybe I was talking with Nick about it. We really want to have, when you plumb it in, you want to use, you know, 1/2-inch tubing or 12 millimeter tubing coming to the regulator. Even if the regulator's got an 1/8 inch port, that it can flow to it, flow through and get to the seal, instead of be hey, we got enough pressure in our piping, but once it consumes a little bit for an upset, it goes to zero. And you want it to, so when you regulate it and you put the 7 pounds in, you open that valve up, it should blow. If it doesn't, that means something's up with the regulator, or the tubing, or the supply isn't what you think it is.
Right.
And I would think that your supply is going to be somewhere around the 6 bar, 8 bar, 10 bar. It's going to be significant. You wouldn't want to go and set it at you have a supply at 2 bar. You want to do something different as far as aligning them, do a pin alignment on it.
Well, one
Everything
thing.
has negatives.
Well, one thing though. Remember, we talked about the elastomer, supplying one elastomer split and one unsplit.
Yeah, one elastomer split, one elastomer unsplit, and the rotors unsplit, and keeping the inboard housing, the inboard stator and the outboard stator.
Oh, they decided on rotors unsplit?
Yeah, there's no need for those as well. It was just the housing that was giving them away. But
okay.
Staying with them, starting with the elastomer probably is the way to go to begin with.
Okay.
Give them that flexibility. And just finding ways to let all the stationary parts be concentric with one another.
Which would be that backside.
Backside bossy.
Okay.